You follow your steps. Even if you seem like you don't know what's going on, you follow the steps, right? Now, the book might not be good about giving you steps whenever you outline. You're going to end up having to work backwards. The example problems give you your steps. Okay, the example problems, you pull the steps out of them. Sorry? Can I make it bigger? Okay. Oh boy. Let's see. Big enough? Tyler? Yes? Okay, good. Okay. And now I gotta move on. Newtons for the next. Okay. 250 Newton force. So first step is always what? Draw a picture. So I have a sled, whatever, it's a nice little box, right? Swing over some surface here, and a force, 250 newtons, 30-degree angle. So 250 newtons, 30-degree angle. And this is normal, right? I mean, whenever you drag a sled along, you don't like get down on level with it and kind of hop along to where you're pulling it perfectly horizontal. You attach a rope to it, you pull it along, and it's at an angle, right? That's how it works. Next step. Free body diagram. So what forces are acting on the sled? Gravity, force pull, normal, towards the wall, force of friction. Good, it goes opposite the direction of motion. Which way is the sled moving?
Oh, right.
Yeah, sled is going that way. So friction would go straight back. Yeah, force of pull. It's supposed to be. My board's off, so I'm having trouble. Let me take a second to realign. You know, I mean, could be. It doesn't align until you lift your finger up. So like if you have a smartphone, you drag it to the keyboard, it doesn't actually choose that button unless you have a swipe keyboard. It doesn't actually choose that key until you take the thumb up off of it. So, you know, if you have an iPhone, iPad, or your parents have one or something like that, you'll notice that you can move your thumb around. It doesn't actually start typing it until you release the button up to let you become a little bit more accurate. Just take a second to come back up. I apologize. All right, so while that's coming up, free body diagram. What's the next step? All right, positives and negatives, and then components. Right, and it doesn't matter which you do first. You can do components, the positives and negatives, or whatever. So let's go into components first. Right. Give myself a XY axis here. What three forces are already on the axis? Gravity, normal, friction. Right. So I don't have to do anything with these guys. Normal, gravity, friction. What do I do with that force pull? Okay, and what are they? Right, so where does the cosine go? Which way, right or left? Right. Okay, so I'm going to label this FP cosine 30. There's the 30 degrees. Which one, or where does the sine go? Up on the Y, right? Because that's where you're pulling. Have it. Doesn't matter. Have it. I like to leave things as letters for us as long as I can. For as long as I feel comfortable doing it. You can put 250 in there. It doesn't matter. I'm going to put 250 in there here in a little bit. Okay. Positives and negatives. Which way do you want to be positive? Up or down? Up. Means down is negative. Right or left? Right. Next step, you get an X and a Y axis. Sum up the forces equals MA. So in the x-axis, what are the forces?
Because on 30
Cosine 30, what else?
minus
Minus FF equals MA. Okay? The y-axis is equals MA. Let's in fact change colors here. Just because we can. What's happening in the y-axis? What do we expect the acceleration to be in the y-axis?
0.
0. So I'm going to make that right-hand side of the equation 0. A is 0 in the y-axis. So it isn't going up in outer space once you down to start. It's 0. Okay? All right. I am trying to find the coefficient of friction. Do I know the acceleration in the x-axis? What is it? 0. Constant velocity. A here is 0. Now we need to pick an axis and start solving. Which one do you want? All for x, raise your hand. All for y. The x is hat. So we start in the x, fine by me. I got 250 cosine 30 minus force of friction breaks into what? Mu times normal. Mu n equals goose egg. I got a problem. What is it? Don't have my normal. Where can I get it from? Y-axis. So let's jump over here. Normal is going to be equal to subtracting Fg, subtracting force of push, sine 30, over to the other side, so technically adding Fg. I'm going to have force of gravity minus force of push, sine 30. Everybody see that? Force of gravity breaks into what? Mg minus 250 sine 30. And I know the mass here, I said it was 15 times 9.8 minus 250 sine 30. Normal force equals what? I'm sorry. 171.5. I'm sorry? 0.75? It's 0.7.
I got 22 too. Definitely.
22 perfectly?
Yes,
22 newtons.
Oh.
That makes sense. That makes a lot more sense. Now, you're used to normal force being the same thing as what? N equals mg. You're used to normal force being the exact same thing as the force of gravity. Not so when we start dealing with forces being at angles, because normal force keeps something from falling through a surface. Well, the normal force is being helped out by the force of pull, okay? By the component, the y component of Fp. So no longer does the normal force have to equal out gravity. It can be a little bit less, right? The y component of pull is helping it. All right, so now we plug this back in, right? Now it's simple algebra. 250 cosine 30 minus mu times 22 equals 0. Mu times 22, negative mu times 22 is negative 250. cosine 30. Mu is going to equal,
Why didn't you just add mu 22?
doesn't matter, right? Dividing negatives now out. What does mu come out to be?
9.8.
Okay. We worked the math correctly. 9 point what? Is that what everyone's getting? Is that a realistic number?
Not
No, not at all. That means Mr. Birch made up this problem that came out really wacky. Okay? Way too much force being
Are you
applied.
do that on
to
the
this.
test? Just to be
I'm sorry?
Are you do that on the test?
No, it has to be just right. No worries. Okay.
I don't understand how we could.
It can't.
What the problem?
Constant velocity. I said that 250 newtons of force were required to pull a constant velocity when in reality it would be a lot less to a constant velocity.
That's not-
This thing should be accelerating. This thing should be accelerating. All right, I want to give you nobody money. Copy that down and give it a shot. Right now.